Hey guys, this looks like a fun one. We're given a cone filled with water and it's flipped upside down. The height of the water goes to here when it's this way and it goes to here when it's this way. And the question is asking what is the height of the cone? If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. For the first step, let's copy this full cone down. We have the dry partial cone up here, and then we have the watery cone down here. These are the 3 cones we're going to use. Let's label them cone A, cone B, and cone C. This cone is completely dry. There's no water here. So let's make the base gray. So we have this cone that has a little bit of water, this cone that's all water, and this cone that's completely dry. Now, each of these cones are going to have a different height. Let's label this height h sub a, this height h sub b, and this height h sub c. And each of them are also going to have a different radius. We can label this radius r sub a, this radius r sub b, and this radius r sub c. Let's clean it up a little bit by moving the labels up here. I think this looks nice. Let's see if we can find some of these values. So for the h sub a, that is this question mark, so let's call it x. It's what we're trying to find. And then for h sub b, that's the height of this cone. We know that's equal to 10. And then for the height of the watery cone, it's going to be the whole thing x minus this 3. Now we have all the heights in terms of x and numbers. Now let's see if we can do anything with these radii. All 3 of these cones are going to be similar to each other. They're all made up of the same cone, but they just have different cuts parallel to the base. So they're all going to be similar. So we can take each of the radii divided by their corresponding heights, and it'll be equal to the same scale factor k. And that'll give us these 3 equations. Next, for the first equation to get the radius all by itself, we can multiply both sides by x. On the left-hand side, the x's are going to cancel each other out, and that's going to leave us with r sub a is equal to kx. And for the same reason, r sub b is going to be equal to 10k. And r sub c is going to be equal to k times x minus 3. Now let's do some substitution. In the place of r sub a, we can plug in kx. In the place of r sub b, we can plug in 10k, and in the place of this r sub c, we can plug in k times the quantity x minus 3. Now we've got everything in terms of 2 variables and some numbers, x, k, and numbers. So what are we going to do next? The volume of this water is the same as the volume of this water. So let's say water sub a is equal to water sub c. So the water in A, it's going to be the volume of this cone minus the volume of this cone. That'll give us the volume of this water. And then to get the water in C, it's going to be the volume of this cone. Next, let's use these notes for the volume of cones. The volume of a cone is pi divided by 3 times the height times the radius squared. So for the first cone, it'll be pi divided by 3 times the height of x times the radius kx, whole thing squared. And then we're going to subtract from that the volume of this cone, which is pi divided by 3 times the height of 10 times the radius 10k squared. And that's going to be equal to the volume of this cone, which will be pi divided by 3 times the height of the quantity x minus 3 times this radius k x minus 3 whole thing squared. Now from here, we can clean up each of these radius squareds. The squared can go to each of these terms. For the first one, the quantity kx squared, the squared can go to both the k and the x. So this will change into k squared x squared. And same thing here, this will change into 10 squared k squared. And for this one, it'll be k squared x minus 3 squared. Each of these cones contains a pi divided by 3 and a k squared. So let's divide each of them by pi divided by 3 times k squared. So each of these matching pi divided by 3's are going to cancel out, and each of these k squareds are going to cancel out. So now we've cleaned it up to this right here. So next we can clean up the left-hand side. X times x squared is equal to x cubed, and 10 times 10 squared is 10 times 100, which is 1,000. And then on the right-hand side, this x minus 3 squared is the same thing as x minus 3 times x minus 3. After we multiply these two together, we get x squared minus 6x plus 9. And then after we multiply these together, we get x cubed minus 9x squared plus 27x minus 27. From here, let's set everything equal to 0. We can subtract x cubed from both sides, and we can add 1,000 to both sides. On the left-hand side, we're going to be left with 0, and on the right-hand side, these are going to cancel each other out, and negative 27 plus 1,000 is positive 973. I like to have a leading coefficient that's positive, so let's divide everything by negative 1. That'll give us 0 equals positive 9x squared minus 27x minus 973. Now from here, I don't think there's an easy way to factor this let's try the quadratic formula. It'll be negative b plus or minus square root of b squared minus 4 times a times c, whole thing divided by 2 times a. And after we do all this, we end up with x is equal to 27 plus or minus the square root of 35,757, whole thing divided by 18. And after we do this, we end up with approximately 12.005 and approximately negative 9.005. Since x is a positive distance, we can get rid of this negative value. And now we have the answer for our question mark. Let's give it a label of centimeters and put a box around it. In this problem, the full cone has a height of approximately 12.005 centimeters. How exciting. I'm pretty sure I saw a puzzle similar to this one as part of a math competition a couple of years ago. I'm so excited that younger students are getting involved in math competitions and solving puzzles like this. The fact they have math competitions like this is awesome. I'm also happy to see Brilliant focusing so much energy on students too. They have solid interactive content on all kinds of topics for grades 5 all the way up to college. And Brilliant has a new tutor, Koji, to make things even better. I really like that I've never seen Koji give away the answer. It's designed to guide students so they get to the answer themselves. All of Brilliant's brilliant interactive lessons are still there. Now there's one more thing available if a student gets stuck. Koji the tutor. Here's an example of what it's like.
3 people know a joke, and the count doubles every day. Build the expression for day 2.
So if a student sees this, they might say, okay, if it doubles every day, let's just put a whole bunch of 2s. And then they could check the answer.
Not quite. Take your time.
So now let's say I just am completely stuck. I'm not sure what's going on. I can go over here and I could say, I'm not sure what's going on. Can you help me?
You're getting the doubling right, but how many people started with the joke on day 0?
So there's 3 people on day 0, so we need to make this a 3. Okay, now I get what's going on. So I hit check.
There you go.
So it told me what I did correctly, and then it guided me on where I was not correct. I still had to figure out, oh, I see, it needs to be 3. And this could happen anywhere in the lessons. If you ever get stuck, you just ask for help. I remember as a kid and also in college, I would intentionally look for more practice problems. I would have loved all this when I was a student, and I'm very happy it's here for students today. If you want to try Brilliant's Tutor for free, click on the link in the description or scan the QR code on the screen. You can upgrade to premium to unlock all courses. And right now, Andy Math viewers can save 20% off an annual subscription at brilliant.org/andymath. How exciting.